Okay, here we are. Let's finish the other side of the test. Now remember, one of your promises to yourself was to read carefully. This is a problem many of us needed to read more carefully. So let's walk through this. It says, the area of a square sandbox is 83 square feet. To the nearest foot, what is the perimeter of the sandbox? So let's pay close attention to what we're saying. So we've got a sandbox, a square sandbox that's 83 square feet. So I'm going to draw that. So I have a square sandbox, right? And it's telling me that the area, that's this area inside here, all this space inside, is 83 feet squared. That's what it's saying. Okay, so now to the nearest foot, what is the perimeter of the sandbox? So what is the perimeter of the sandbox? Remember, what is perimeter? Perimeter is, I highlighted perimeter in pink. The perimeter is the distance around an object, no matter what the object is. Circle has a special name, but it's just the distance around the outside edge. So now you are not expected to know what the square root of 83 feet is, right? And we're given this direction to the nearest foot. But I do know that a square, another square that would be just ever so slightly smaller than this, would have an area of 81 square feet. And 81, as I've told you, you've got to know your square numbers. If this has an area of 81 square feet, well, heck, I can find the side length of this. Because remember, square just means you have each side, the area is always just the length times the width, and in a square, they're the same thing. So I need two numbers. One multiplied by itself is 81, or the outside here is going to be the square root of 81. Well, what's the square root of 81? Well, it's 9. So I know for my near square with an area of 81, each side length is going to be 9. So that means this edge is going to be close to 9 as a side length. But it's not, the question, remember, is not asking me how much the side length. The question is asking me what's the perimeter. So what I need to do is I need to add up all four sides. And you can see there, 4 times 9, 36. So the correct answer, H. So the nearest, so this, whatever the sandbox is, it's square sandbox, that's 83 square feet. I found, I did it with an area of 81 square feet. A lot of folks misread this one, I believe. Number 11, which number best represents the point graphed on the number line? So let's look at this number line. So it looks like the point is between -4 and -5. So let's see what our options are. Well, right away, we can cancel A and D because we haven't dealt yet with how do you take the square root of a negative number. So these two right there go away. That's not an 8th grade standard. So I'm left with these two. B is the opposite or negative square root 20. And C is the opposite or negative square root 25. Well, 25 is a perfect square. So C is -5. But if C was the answer, wouldn't the dot be exactly at -5? Yes, it would. And since the dot's clearly not at -5, it's going to be a little bit less than -5, right? It's going to be a little bit less than -5. So -20 would be between -16 and, I'm sorry, opposite, I wrote that wrong. It'd be between the opposite of 16 and the opposite of 25. So correct answer is going to be B. Number 12, multiply 5.3 times 10 to the 5th times the quantity 4 times 10 to the 3rd. Show your work. So this is worth 3 points because now I'm asking you to show your work. So when we multiply in scientific notation, we're going to deal with the values here, the decimal values, separate from the powers of 10 because that's the same base and I can apply the exponent rules. So you can see I've highlighted the parts I'm going to deal with here in pink and in yellow. So the pink part, I'm simply going to multiply 5 3/10 times 4, which is 21 2/10. But this is not scientific notation, right? If I move the decimal over 1, I have 2.12, but then I have to multiply back a factor of 10, so make sure it equals 21 2/10. So 5 3/10 times 4 is going to be 2 1200ths times 10. And then I deal with same base. When I multiply the same base, which is what I'm doing here with 10, I add the exponents. So it'll be 10 to the 5 plus 3 or 8. So I'm left with 2.12 times 10 times 10 to the 8th. Well, again, I'm multiplying the same base. 2.12 times 10 to the 1, that's this exponent, plus 8, or 1 plus 8 is 9. Correct answer, 2.12 times 10 to the 9th. Number 13, Tito is installing a new kitchen floor. The kitchen is square in shape, okay, and has an area of 175 square feet. What is the length of one side? Okay, there's my question. What is the length of one side of Tito's kitchen to the nearest integer? Draw the kitchen and label according to the directions. So let's do the drawing first. Here's Tito's kitchen, right? It's a square, has an area of 175 square feet. I want to know what the length of a side is to the nearest integer. Well, conveniently, what I need to know is what square number is directly below 175, 169, and what square number is directly above 175, 196. And when you take the square root of 169, you get 13. When you take the square root of 196, you get 14. Well, 175 is clearly closer to 169. So the length of one side to the nearest integer, 13 feet. This needs to just slightly. Oh, look at that. We have another scientific notation computation question. This time we have an adding question. 3.52 times 10 to the 3rd plus 2 6/10 times 10 to the 4th. Show your work. Adding's a little bit different, but yeah, we want to make sure that we are adding the same thing. So right now, you simply just can't add 10 to the 3rd plus 10 to the 4th. It doesn't work that way. But what we can do is we can make 10 to the 4th look like 10 to the 3rd. So I can make 10 to the 4th. Let's get a highlighter here. I rewrote 10 to the 4th as 10 times 10 to the 3rd. Remember the exponent here is 1. And now I have some parts that I can add together. So this number here is in 10 to the 3rd. And now I have this, it's 10 to the 3rd. Now I've got something that I can add together. And also, we took 2 6/10 and we multiplied by 10, and we've got 200, and we got 26. Shifts the decimal over. So 2.6 times 10 is 26. Right? Don't be fooled. That doesn't mean anything there. That's not 260. So now we're just going to deal with the two parts. I have 26, and now this is a decimal, and I'm going to add to 26 3 5200ths. And both of these are times 10 to the 3rd. So I'm adding like things. Cats with cats, dogs with dogs, apples with apples. So 26 decimal 00 plus 3 5200ths is going to be the 2 and the 5 will come down. The decimal point will come down. 6 and 3 is 9. Bring the 2 down, so I have 29 and 5200ths times 10 to the 3rd. It's almost in scientific notation. I'm going to have to move it over 1, right? And that's going to if I move it over to the left one, that means I have to give another 10 back here. So now I have 2 decimal 952 times 10 times 10 to the 3rd. Again, I'm multiplying same base, add the exponents. 2 decimal 952 times 10 to the 4th is your answer. Let's see, we're getting close to the end here. Solve the equation x squared equals 100. Recall solutions must be written x, the variable equals something, right? Because once I start with an equal sign, I must always have an equal sign. So I know what numbers, when multiplied by themselves, equal 100. This is an equation. So when I have an equation, I must do to both sides. So how do I undo a square? I take the square root. So if I take the square root of the left side, I must take the square root of the right side. So what number or numbers, when multiplied by itself, equal 100? Well, there's 2. 10 times 10 is 100. Negative 10 times negative 10 is also 100. So this equation has 2 solutions. X equals positive 10 and x equals negative 10. So the complete answer would have had x equals positive and negative 10. There's more than one way you could write this, but this answer should have 2 solutions. This is the first time you've looked at solving something that is to the power of 2. And so this is an 8th grade standard here. One more question. Evaluate the square root of 121 plus 2 to the 3rd power all raised to the 2nd power. Well, square root of 121, that comes down, plus, here I have a power raised to a power, so 3 times 2 is 2 to the 6th, right? The base comes down. Keep the base, multiply the exponents. The square root of 121 is 11. 2 to the 6th is 64. 11 plus 64 is 75. There you go. So I hope this video helps. Make sure you're clear about the things you need to become clear on. Write your questions and get ready if you're one of those folks who needs to prepare to take a retake. Hope this helps. Bye for now.